Hello, and welcome to our video lesson about correlation coefficient. Correlation coefficient is a measure of how well data points line up. In a perfect world, data points would line up in a perfect straight line, but in reality, it's a little more scattered. Sure, I can find a trend, but it's not really exact. Now, here's some fun facts about linear regression. The correlation coefficient ranges from -1 to 1. If r is equal to 1, that means it's a straight line going up. If r is -1, it's a straight line going down. And if r is 0, then that means all the points are scattered all over the place. Now notice 1 and -1, the line is straight. Negative doesn't mean negative in value. Negative just means direction. Positive values go up, negative values go down. So with that, a line where r is -0.958 actually has a stronger correlation than a line where r is positive 0.817, because the absolute value of the first line is more than the absolute value of the second line. Then again, the negative just indicates the direction. Now, correlation does not imply causation. Just because two variables have a strong correlation does not automatically mean that one variable causes the other to happen. Could be a coincidence. It could, but if there's a correlation, then whoever's researching this would have to do some extra research to see, okay, what's going on? Why? Anyway. So, in our examples that you're going to do on the homework, what we're going to do is we're going to find the correlation coefficient. There's two ways of doing this. You can do this by hand, which will take you forever to do. It will take 1 hour to do one question. You don't have time. Or we can use StatCrunch. StatCrunch is a program that comes with MyLab statistics. Here's how to use StatCrunch to find the correlation coefficient. So, right now you're given a question that looks like this. All right, do you see over here where it says click here to view the data table? Click on that. Let's see what happens. And notice it brings up a data table. You have age and you have vocabulary size. Now notice right here, it looks like a little square. Click on that. And this opens. It says open in StatCrunch, open a clipboard, or open in Excel. I want the one that says open in StatCrunch. So this is StatCrunch. It comes up automatically. And it also loads your data up, so you don't have to type in your data. So I like that. All right, here's what we're going to do to get our answer. At the top, you're going to see the word stat. If you go down a little bit, you will see the word regression. And then you will see the word simple linear. Click on that. So it's going to bring up this screen. All right, when you get to the screen, where it says X variable, type age. Where it says Y variable, do vocabulary size. And then when you're done with that, press compute that's located at the bottom. Let's see what happens. Brings you a lot of stuff, but what I'm interested in is the correlation coefficient. And it is right over here. Let's see if I can circle it. There we go. So we rounded that to r equals to 0.973. But also notice that there's an arrow at the bottom. Watch what happens when you click on that. It brings up a picture of your graph. So you don't have to graph it by hand because this will graph it for you. All right. So we know that r is equal to 0.973. And because this is more than 0.800 and it's positive, I would consider that to be a strong positive relation, which means as the age increases, the number of vocabulary words also increase, which in real life makes sense because when someone's born, they don't know how to talk, but then when they listen to words being spoken, then their vocabulary builds. Okay, now click on the box with the data values, which you did earlier, and also click on the link that says Pearson coefficient values, like you see here. Notice that if you count, there are 11 ordered pairs right here. So what I'd like to do is look up n equals 11 and 0.01 on our chart. And it intersects at 0.0735. This is our Pearson critical value. What's significant about this is this tells us, what this means is if our R value is larger than 0.735, then that means there is a linear correlation. And since 973 is larger than 735, that means there is sufficient evidence at 1% to conclude that there is a significant linear correlation. All right, so StatCrunch is basically going to do this for you. Okay, for our next example, they like to compare height with IQ. We're going to graph and find the correlation coefficient. All right, well, again, we're going to press stat regression simple linear, and we're trying to get our correlation coefficient, and we do find it. It's right here. Well, notice this. R is equal to negative 0.076. That's really close to 0, which tells me that there is not going to be a linear correlation, which makes sense because how tall somebody is doesn't tell you how smart they are. Height and IQ are totally unrelated. Okay, well, there are 8 pairs. And I would like to look for what happens when n equals 8. When n equals 8, the Pearson critical value is 0.834. The problem is 0.076 is smaller than 834. So when R is smaller than the critical value, that means there is not sufficient evidence to conclude that there is a significant linear correlation. So with that, you should be able to do questions 4 through 7 on homework 9. If you have any questions, please let me know. Otherwise, have a great day.